Hi, so for my IA video, I'm just going to solve a question on functions as if I was on Zoom office hours. So here we're given that f is a function from x to y and g is a function from y to z. And we want to prove that if f and g are one-to-one functions and g of f, then g of f, the composition, is also one-to-one. I note that these f, g are arbitrary, and then sets x, y, z are also arbitrary. So before we start on a question like this, I think it's good to just to go over some stuff to make sure we're on the same page. The first thing I want to talk about is the domain and codomain of the composition. So if I have that g of f is like some function, another way to write this might be to say g of f of x, where x is in big X, the domain. And this basically, this comes from the definition of function composition, which we can go over later if we have to. And then this basically tells us that the function g of f takes some input in x, maps it to y because it does f of that, and then maps it to z. So our composition, g of f, leaving out the middle part, goes from x to z. Sorry about that. Okay. Another thing I thought would be important to mention is just the general format of an injectivity proof, or a one-to-one proof, sorry. So one-to-oneness in general means that if you have some, I'll use f here, you have some arbitrary function f, then if you have input f of x, you have input f of y, where x, y are in your domain, then you just do your math, and you get that x is equal to y. This implies that x is equal to y. And this is just the format we want to choose, so what we would do is we would say choose, or so we choose an arbitrary xy in the domain. And the reason we choose arbitrary is to make sure that everything is generalizable, like our result is generalizable. And then we just show, so choose arbitrary xy, suppose this is true, show this must hold. And that is a general way to show injectivity. So we can follow that template now and use that for the problem here. So let's say we have x1, x2 in the domain, which is x, as we discussed, where x1, x2 are arbitrary. We suppose that g of f of x1 is equal to g of f of x2. And then from here, what we can do as our first step is write down g of f of x1 in this form, just using the definition of function composition. So when you're doing your homework, make sure you justify by definition function composition. Just maybe elaborate like a sentence about that. So now I'm going to do an intermediary step that is not required, but I'm going to do this just to illustrate what's going on here. So we can say that y1 is equal to f of x1, and then y2 is equal to f of x2, where y1, y2 are in y, the big set y. And then that lets us rewrite what we have as g of y1 is equal to g of y2. And now this is where we use the problem. So recall that g is 1-to-1. So because g is 1-to-1, we have that y1 is actually equal to y2 here, which means that, and because we said y1 is equal to f of x, so f of x1 is equal to f of x2. And now again, we just use the fact that f is 1-to-1, which means that x1 is equal to x2. And we're done. That actually concludes our proof. So what we've done is that we supposed that the outputs of, if I zoom out just to show everything, so we suppose that our outputs for some arbitrary x1 and x2 are the same, and we've shown that this has to imply that x1 is equal to x2. And that shows injectivity.